Welcome back to Mr. Aparicio's geometry course. Today we are learning section 1.5 of geometry, which is all about naming and measuring angles. Let's get into it. Angles are crucial in geometry. We're going to have them in every shape that we learn about throughout the year. It's very important for us at this stage to be able to name and identify angles. So a precise definition here. An angle is just two rays that share the same endpoint. All right, and the endpoint of a ray is called a vertex in an angle, right? Where those two rays meet each other is called a vertex. So as we look at the figure here, the vertex of this angle is going to be point Q. All right, in this example, we're going to go over how to name our angles. So there's three ways that we could do it. If we have this number in the interior of the angle, we can name it that number. So I could call this angle 1. Our angle symbol looks like this, kind of like a little witch's nose. So I call that angle 1. If I have just a single angle, no other angles around it, no angles adjacent to it, I can name the angle with its vertex. So I could call this angle Q. But what we really need to get down is naming angles with 3 points, because we're often going to have multiple angles with the same vertex, in which case we must name with 3 points. And the only rule here in naming is that the vertex must be the middle letter in the name. So I can call this angle SQR or angle RQS using my points. Again, that's angle SQR or angle RQS. Here's an opportunity right away to see if you can name angles using points. In this figure, there are actually 3 angles. I'm sure most people see this little angle here and this little angle here, but when we combine those together, we get this large angle over here. So pause the video, see if you can name all 3 of these using 3 points per name. Okay, let's see if you have accurate names here for this angle. I'm gonna start off with this one over here. Using the 3 points that are on it, remember the rule being that the vertex has to be in the middle. So I have X, U, and Y. I have 2 ways that I can put U in the middle of this name. I could call it angle XUY, or I can call it angle YUX. Both of those would be appropriate there. So we look at the other little angle. So looking at this one now, again, I have the 3 points that are on here. Just need to make sure that U is in the middle of the name. So I can call that angle YUZ or angle ZUY. Both of those would be appropriate for that one. And we have our large angle. So that's these little ones combined give us this. Again, X, U, and Z are my points here. I just need to make sure that the vertex where my angle opens, where my rays meet and share that endpoint, that point has to be the middle letter in the name. So I can call this angle XUZ or angle ZUX. So the depth that we want to get to is to be able to name or identify any angle in a figure like this. The first thing I want you to notice here is that all the sides of the angles in here end at point G. So G is the vertex for everything in here. So any angle needs to have G in the middle. And there's 2 skills that we want to take away from an example like this. First skill, if I highlight an angle like this one, you should be able to name this, right? It has points A, G, and C on it, and remember the vertex needs to be in the middle, so I can call this angle AGC or angle CGA. All right, just give you a few little practice rounds here to see if you can figure it out. Can you name that angle right there? You say FGD or DGF would be appropriate names for that. You should be able to name this angle right here. Angle BGE or angle EGB would be an appropriate name for that. You also, though, need to be able to do the reverse of this. If I name an angle, you need to be able to identify it in the figure. So if I say to trace angle FGB, well, that's a simple thing to do. You just start at F, you go to G, then go to B. There's an angle FGB. Let's just make sure that we have a clear understanding here that the angle is the interior. It's all this stuff in between. Okay, that's angle FGB. Angle CGE, that would be all this stuff in between sides GC and GE. That's angle CGE, right? Angle BGA, that's this stuff right here in between our sides. So you can trace an angle with the understanding that the angle itself, the measurement of the angle is in the interior portion. That being said, let's learn how we can actually measure angles and figure out the degrees. That's the unit that we're going to use inside of our angles. As we're measuring angles with the protractor, we can now start to identify the types of angles that we're measuring. We have 4 basic types of angles, 4 ways to classify them when we're using degree measures. One of them is called the acute angle. Acute angles are less than 90 degrees. And what that will look like is it'll just look like a smaller opening than a capital L, right? Just a little bit smaller than a capital L. So a good example of that would be like this angle right here would be acute. Right angles are exactly 90 degrees, so those look exactly like a capital L. Right angles are always shown with that little box in the interior. An obtuse angle is more than 90 degrees, so that would be an opening larger than the capital L, so that would look like this. And then one you maybe have not heard before is the straight angle. Straight angles are exactly 180 degrees, and straight angles look like lines. In fact, they're opposite rays, if you remember that from section 1.1. We're now going to combine all the knowledge that we've learned in this lesson so far using our protractor postulate to measure different angles here in this example. We're going to start with angle MKN. We're going to use our postulate to find out how many degrees it is and then classify it as acute right or obtuse. So the first step here is identifying where that angle is on our protractor. And I think the easy way to do this is to just trace it with your pencil, right? You can highlight it from point M to point K to point N. Tracing that would be like this. There's angle MKN. To find the amount of degrees on the interior of that angle, remember we're going to find the difference of the values where our sides cross the protractor. I'm looking at the outside set of numbers, because that's always what I do. Again, you're just going to pick a set of numbers and stick to it. On the outside, side KM crosses at 145, side KN crosses at 180. Remember, we're going to do the big number minus the small number. So 180 was my large value minus the 145, my small value, gives me a 35 degree angle for MKN, which of course would be an acute angle because it's less than 90 degrees. I'll do one more here with you. We'll go over that angle NKJ. Again, tracing it can help me find the angle on the protractor. So from N to K to J would be this angle. And then again, I'm going to look at my outside set of numbers to see where they cross. The outside here crosses at 90, over here crosses at 180. So side KJ at 90, side KN at 180. Again, we're going to do the large value minus the small value. That's 90 degrees. That is a right angle. If you're one of my students, you have several other examples to practice with in your packet. Go ahead and pause the video and see if you can find the measure of those remaining angles. Here are those accurate measurements. Hopefully you did well there. That's going to wrap up our lesson for today. We'll see you in the next one, guys. Bye.